Okay, here we are. This is Chapter 11, or Unit 11, RT2, Lesson 1. We're going to talk today about simplifying some square roots. Vocab that we'll need to know for today are factors, radicals, and radicand. So let's talk about the factors real quick of 36. What are the factors of 36? Well, throw one out there. Sure, 36 could be 6 times 6. Those are factors. What's another set of factors for 36? 36 times 1, yep, absolutely. That's always an option. 9 times 4. Right? Anything else out there? 18 times 2, maybe? 18 times 2. Okay. So each of these are called factors. Okay. What we're going to be doing today is doing something like, I don't know, taking the square root of 72. Right? Last semester, you would have said, well, Mr. Ludd, if you had me. If you didn't, well, then whatever. But you'd probably tell Mr. Donald or Mr. Tuthill, you'd say, well, I know that the square root of 72 has to be somewhere between 8 and 9. And you'd use your calculator and you get some decimal value. Today you're going to get an exact value. All right, so how do I do that? Well, I take this radical. This is the radical piece. Right, here's the radical. That's the radical. This item inside is called the radicand. Radicand. Okay, and I'm going to look for factors of that radicand that are reducible in a square root. Okay, so you can go the long way on these problems or you can go the short way. So here's my radical, here's my radicand. I'm going to kind of think about the factors of 72. Well, let's talk. 9 and 8, sure, absolutely. What else? 72 and 1, okay. What else? Does 36 go into 72? Twice, right? 12 and 6, good. 12 and 6. Okay, one of these is going to be more beneficial to use than the others. I want to look at my factors, and then I want to identify the largest possible square root. Perfect squares. Oh, my perfect squares, what are they? How about 1, and then 4, and then 9, and then 16, 25, 36. What comes next? 49, 64, 81, and let's stop at 100. Okay, do I see any of those numbers up there? I see a 9, yep, I see a 9. Do I see a larger one than 9? Yeah, oh yeah. Once you find the largest possible perfect square that goes into a number, you want to use those. Use those. Why? Because it will be fully reduced. So I'm going to rewrite the square root of 72 as the square root of 36 times the square root of 2. What is the square root of 36? 6. So the answer to this in exact form is that the square root of 72 is equal to the 6 times the square root of 2. Okay, so let's say just for a moment that you went the wrong way with it, and you said the square root of 72. You said I'm gonna go with 9 and 8. Okay, so then that would be 3 root 8. You're absolutely accurate with that, but you haven't fully reduced that. 8 can be reduced. What perfect square goes into 8? Yeah, well, 4 and 2, right? So this would be 3, and this would be the square root of 4 times the square root of 2, right? Do you see how square root of 8 turned into square root 4, square root 2? What's the square root of 4? 2. So this is 3 times 2 times the square root of 2, which is 6 square root of 2. You get the same answer regardless. Now, this, I like to use a metaphor. Mom or dad or grandma or grandpa come in and they say, clean your room. And you're like, yeah, okay. So they leave, and you start kicking stuff under the bed, and you're like, oh yeah, let's just shove all that stuff in the drawers, and we'll vacuum just what's visible, right? That's how I equate this version of getting there, right? Because yeah, I kick things under the bed, and I get an answer, and mom and dad or grandma and grandpa walk in, and they say, that's not done yet. And you're like, dang it, now I gotta do it again. Okay, fine. Finally, I get to the right answer. Instead of just do it right the first time, and you have less to do. Then you don't have to do it another time, right? Metaphors, life, yeah, math. Cool. Okay. Okay. Let's talk perfect squares just for a moment because you're gonna need to know these. If you're proficient up to, I would say, probably 13 squared, you're good. Okay. So I think we can all agree that we know 1 times 1 is 1, 2 times 2 is 4, 9, 16, 25, 36, 49. Let me keep moving here. 64, 81, 100. This is where childs start to get a little bit less confident. 121, 144, 69, 196, 225, 256, 289, 324, 361, 400. Oh, now what? 441. So you did 620, 625. I knew it. I knew it. Right? I knew it. Okay, so why are these useful? Yeah, I mean, if I give you this, find the square root of 324. You need to know that that's a perfect square. You don't have to find factors of that, right? Don't start thinking of factors of 324. Understand that the square root of 324 is 18. It's done. Right? So these are your gimmies. If I give you one of these, don't do the tree diagram type stuff. Don't do that. Just know that the square root of said numbers are these whole numbers. These are perfect squares. It's the numbers in between that give us headaches. All right, so let's get down to some examples. We know this, right? Square root of all of these are what we just talked about. Let's keep moving on to some simplifying. Okay. So square root of 48. Right? We're going to reduce this. We're not doing a decimal approximation. Okay? Square root of 48. Who sees it right away? Largest perfect square that goes into 48. Okay, I got a 1 and a 48. That's not on neither of them on there. Okay. Yeah, that's not going to work. Does 4 go into there? 12 times. Okay. I like that, but I also like 16 and a 3. Which one's more advantageous? 16 and a 3. So step 1, find the largest perfect square. I did. It's 16. Step 2, rewrite the radicand as the product of two numbers. Okay, I just figured out I want 16 and I want 3. Well, I guess that's step 3. I guess that would be step 3. Step 2, because we're very particular. Okay, then I split it, and then now I reduce it. 4 root 3. Good? Should we get more difficulter? Yes, it is. It's Spanish. Yes, it is. I took Spanish for like 3 years in high school. Huh? Hey, I want you to work with a neighbor. Do this, okay? Try these 6. Some might be easier than others. Good luck. I'm waiting for it. Hey, Nick, tell me which one you got. The first one, what'd you get?
3 root 3.
Good, 3 root 3. That away, Nick. Nick saw that 27 breaks into a 9 and a 3, which the square root of 9 is 3, and the square root of 3 stays the same. 3 root 3. Good job, Nick. Somebody else for square root 50. Yes, sir?
5 root 2.
Yeah, you did square root 25, square root 2. Find the biggest perfect square, right? And then reduce it. Yeah. Somebody else got the third one? Square root 252? Yeah, Adele? 6 root 7. She said 36 times 7 equals 252, and you're right. Reduce that. What do you think would be the best method on going about this? Guess and check, which would be, I'd take 252 and I'd divide it by numbers that I think might go into it. And if I get a whole number, so if I took 252 divided by 7, or divided by 36, I get 7. So I can split it and I can reduce it. Good. Nick, do you have a question?
Yeah.
What do we got? Anything number 4? Guess what? It's irreducible. You can't reduce it. Oh, such a mean teacher. You're so bad. Yeah. Protein powder. Those are the gains. Those are the mathematical protein powder. Those irreducible. You just think about it too hard and then you realize, oh, it's not reducible. How about 121? 11. It's just 11 because it's a perfect square. You don't have to do any multiples or factors, right? Anybody for square root 80? Yes, Kian. 4 root 5. 16 goes into 80 5 times. And so I can reduce that. Way to go, Kian. No ruler for you today. Let's go to this idea of unsimplifying. If I want to turn a reduced radical or a partially reduced radical into a single radical, I can unreduce it or unsimplify it. Okay, here's how we would go about that. I want to write 3 as the square root of something. 3 is the square root of 9, right? So 3 root 8 is the same as the square root of 72. This is the unsimplified version of that. 7 is the square root of what? 49. 49 times 5, that's 245, I believe. No? Yeah? Yeah. So 7 root 5 is equal to the square root of 245. Now this isn't something that you'll be asked to do frequently, but it builds the inverse operation thinking, right? It builds the backwards process, which actually strengthens what we're trying to do in the previous slides. Okay, so that's unsimplifying. How would this look in Schoology? Okay, this is important. If you get an answer like this, right? 5 square root of 2. You're going to write 5 because we can't like do a radical in Schoology. You're going to write 5 square 2, or in West Virginia language, square root 2. That's how you type that in. How would you type this in? 11. Yeah, someone last year wrote. Huh? No, you don't be doing that. You just type in the number. If it reduces fully, you just type in the number. And even that's wrong. You would want to write square root 1. Right? Yeah, okay. That's how you be typing in your answers. You got it? Like, subscribe, donate some squirrel meat, whatever. 100th subscriber gets an airsoft gun with a grocery store Gaines decal on it. Oh. Okay, still recording. Probably stop this now.